got some people filing in. Hello, everyone. For those who are currently in, we're just going to give people a few minutes to file in, and then we can get started. I don't have. You have your key? Yeah, do you mind getting it?
Yeah.
Okay. Do you know where the pipe is?
Do we have questions afterwards?
Yes, we will. We will definitely have time for questions. All right. Got about 1 more minute before we get started here. And it is on the hour, 11 o'clock now, so we'll go ahead and get started. So thanks for everyone for joining the May 2021 edition of the Can Journal Club. I'm joined here with Dr. Markus Roggen, and he is up in Vancouver at UBC with his company, Complex Biotech Discovery Ventures. He is CEO. So Markus, would you like to tell us a little bit about what you've been doing with your work at CBDVL and really what you're working on currently?
Sure, will do. Actually, that's the beginning of my slides. So I get to that as soon as I share my screen.
Okay, sounds good. And a little bit about the talk today. I guess, would you like to share with the participants here a little bit about the work you've been doing today? And I guess how fresh it is?
Sure, yes. So we finished the slides while I was waiting in this Zoom call. My colleagues are on the call as well, and they will see I haven't even been able to put in the latest pictures that we were just working on because this is as fresh as it gets. It turns out that we were just able to finish enough interesting data points for this presentation today concerning cannabis smoking and vaping, and I'm quite looking forward to share this all with you. So should I just share my screen?
Excellent. Yeah, let's go ahead and kick things off here.
I cannot share my screen.
You cannot share your screen. You should be able to share your screen. Let's see, just give me 1 moment here. Okay, so I believe you should be able to show
now. I can. Now
yes,
I can.
We go. Okay.
Okay, I share my screen. You see my screen. I go on full screen. Then you see all this. I make this minimum. Okay, so you all see my full screen, I assume?
Yep, we can all see.
Okay, so then welcome to the Cannabis subdivision of ACS Journal Club in May. I will present on cannabis smoking and vaping, and I recently learned what the rest of a joint is called when you're nearly done smoking it. So the Roach. At the end, we will actually talk about our latest work of quantifying cannabinoids and terpenes on a puff per puff basis. And so then we can finally answer the question, is it best to be first in line of smoking a communal joint or last? That is from the cannabinoid inhalation aspect, not from the health and safety side, considering viruses and bacteria going around currently. So we just stick to that field. Okay, so quick introduction about who we are. I would normally say Complex Biotech Discovery Ventures, or for short CBDV, is a research venture, but it turns out we were a research venture because yesterday we got acquired by Delic Corp. So from here on out, we will be known as Delic Labs. And that's about the changes that are going to happen. So you will, as you see on the bottom right, see a new design and a new name for the company, but what we do stays the same. We are a laboratory based in Vancouver, Canada. We are based on UBC grounds. We have strong connections to the university so that we have access to their expensive toys like NMR and X-ray. And we hold licenses for research into cannabis and psilocybin mushrooms by Health Canada. So that's the reason I am in Canada, because here's a federal legal system to do so. And we do, as I like to put it, do all the boring stuff of cannabis and mushrooms. We focus on process design, process optimization, process analytics. So we've done kinetic studies on solvents. We optimize CO2 extraction to more than just 2 factors. We look at way too many right now. And then we built models and methods for in-process analytics like IR control for decarboxylation, as you might have heard of already. But we don't do it all by ourselves. We do a lot in collaborations with other groups and experts, obviously University of British Columbia, as we're located there. We do a lot of work with the chemistry department. We also do collaborate with Loyalist College in Ontario. They have a very nice cannabis course for students that want to break into the cannabis industry. I taught there, and they also hold a license, so they do work that can help our problems, or we help with their problems. And then there are Dr. Monica Villalpando and Dr. Linda Klumpers, who I think both have already been on the journal club. They are experts in formulation sciences and clinical pharmacology, respectively, in the field of cannabis. And then we work with industry partners and instrument manufacturers like Metal Toledo, Fridge, PerkinElmer, and Agilent to use or to optimize their analytical instruments for the needs of the cannabis and psilocybin industry. Okay. So as I said, we have a diverse set of projects we work on. They're generally focused on the chemistry side. And so a lot of work is chemometrics. That's all the optimization parts, the kinetic studies I mentioned already, and process analytics and computational studies. I point out computational studies because as we do collaborative research, we are looking for you. This slide, just added, comes from a binding study that my colleague, Dr. Tom Dupre, just finished on how the different isomers of THC, so delta 8, delta 9, and delta 10, and all those possible stereoisomers, bind to the CB1 receptor. So we have done this now on the computer, and we found some interesting results. And we are looking for someone who is maybe doing that in real life, some in vitro binding assays, functional assays. If they are working on this, we would love to collaborate because we might add some insight from the computational side. So please reach out. Although I said the company name changes, that email will continue working, so you can always email me under markus@cbdvl.com. So with that, I welcome you to the group meeting of my team, because we have weekly group meetings, and I was slated today to talk at 3 p.m. about a scientific topic. And so I just combined it with today's journal club. So my team is on the call and will listen in. but I'm happy to share this more as a broad presentation to the audience of CAN. So we are talking about cannabis smoking and vaping. And I start off with a bit of a literature review, as it's the journal club, of what we're dealing with, what the problems and pitfalls might be. And then at the end comes the fun part, the puff per puff studies that we've just completed, or that we're currently working on. So I will share these results with you. Okay, so what is the impetus or the interest in looking into cannabis smoking and vaping? I think it came to the forefront in 2019 when EVALI came about and started killing users of illicit cannabis vape products. And there are some numbers, right? 2,600 cases in all 50 states, and nearly 60 people died. I actually checked. There isn't really any data or any knowledge that any of the EVALI problems came up here in Canada, because Canada already at that time had a federally legal cannabis system. So the black market, while still big, wasn't really that big a problem compared to other states in the US where cannabis was generally illegal. And also it's interesting to think back to 2019 when we were scared about that caseload of a lung illness. But nevertheless, it brought to the forefront that inhaling products, formulated products, bear risk. And so maybe one should start thinking not only about what is in a product, but also what comes out of a product when it is burned or vaped. So, well, we are chemists, and chemists is the change of molecules, and so that's the fun part of it for us, but it is can potentially be a risk factor for the consumer. So for grass, oh, sorry, for the EVALI issue, the main culprit identified was the vitamin E acetate, shown top left. Here, this molecule or this compound is a nice, no, I'm putting that here in air quotes. It's an ingredient that is handy to use by illicit or nefarious actors to stretch their cannabis product, because vitamin E acetate has about the same appearance and viscosity as THC distillate. So for very cheap, you can stretch your vapes. A problem is vitamin E acetate as a vaping ingredient is not a great idea. And then I put up some other compounds, MCT oil, as it is often used in vape products until people learned better, and generally used PG and VG from the nicotine space, although they are a bit problematic as they are so polar, as you can see with the alcohol groups. They don't really like to mix with cannabis products, with THC and CBD. And then I have also diacetyl on there, the butter flavor that should not be in vape products, but we had seen that early on. So as I'm putting on this slide that all these ingredients are grass, I just quickly want to swing over to grass, because I love this discussion that people come up at conferences. You remember those when we were all in one big room and talked to each other very closely, slightly shouting, particularly on the grass issue. So grass is generally recognized as safe by the FDA, but it's for food aspects, not for inhalation. So you can eat them, you shouldn't inhale them. And just to make the point that grass is maybe not the greatest and be on end all is grass GRAS designation used to be for trans fats. I think we learned better by now. Also, GRAS is salt water, and I think we can agree you should not inhale that. And then, contrary to popular belief, butane is not GRAS. So that was what I'm referring back to at the cannabis conferences. People of BHO would always say it's okay to inhale butane. So one, it's not GRAS, and second, I'm still not sure if it's a great idea to inhale butane. Okay, so how are we doing these studies? We could just recruit students on campus, and I'm sure there are enough eager students who would do all the inhalation studies for us and give us a marked questionnaire back, but we wanted to put some numbers onto it. So we are using this smoke cycle simulator by Combustion. Basically, it's a lung. It functions like a lung, so we can program it that it starts inhaling the vape cartridge or the joint. I will go into the details of what we are seeing in this slide on the next slide. It basically allows us to program the inhalation profile, so how long, how often, and how much you inhale. And then we can capture those both on pads or impinges or the lung bag. The lung bag is this large glass tube with a pink bag on top of the machine. Okay, so here's a closer look on it. So if we start on the pictures on the top right, this is our 3D printed mouthpiece for the vape cartridge, and then our very high-tech holders for the vape pad. It's a glass fiber pad you see on the bottom left of picture, where we basically capture the aerosol, so the heavier aspects of the vape and smoke that comes out. And then in the middle picture, you see a close-up of the impinger, where we would then capture lighter, more volatile compounds that we would then identify on the GC. Oh, sorry. So a few things on the text here to point out. So in the literature, this temperature of inhalation of like the gas, the air, the vape, the aerosol, whatever you want to call it, that you inhale is around 40 to 60 degrees Celsius. So 44 was a literature value I could find. And I talked to some other experts in the field. So that's not really that hot. Which is good, right? You don't really want to inhale 200 degrees hot air. That doesn't. Have you ever sat in a sauna where it's like 89 degrees Celsius and that already feels hot? So if you would go to the boiling points of compounds, that's a bit much. So a few things we found. First up, if you smoke a joint, which is THC acid in the flower, you actually inhale THC. So decarboxylation is effectively complete. We did not find any THC acid on our pad when we captured it. And then, yes, we found some toxicants, and I get to that in a moment. But before we go into the deep discussion here, I just want to remind everyone that what the boiling points of our main ingredients here are. So THC has a boiling point of 157 degrees Celsius, or like 155 to 157, or like 157 to 160, depending on which literature you look at. But the important point is that 0.05 millimeter of mercury. That's a really hard vacuum. So if you Google it, boiling point of THC, you will find on Leafly and 4,200, like these industry-specific websites that the boiling point is 150 degrees. Like, how the hell would that work at 1 atmosphere? It doesn't. So we have to understand that. And if the smoke temperature that you inhale is 44 degrees Celsius and the boiling point of THC, if you use a normal graph boiling point is 425 degrees Celsius. So that THC is not boiling at all. And I would even wonder if it ever boils at that temperature. It probably degrades beforehand. And then also here, myrcenes, so monoterpenes or sesquiterpenes here referenced by or exemplified by homulene, boiling points over 100 degrees Celsius. So we are now wondering what gases we are inhaling and what aerosols we're inhaling. So I would assume most of these things are actually droplets. Small fine droplets, so hence the filter pad. Okay, so let's quickly dive into the literature. What are we dealing with toxicants? So our classics PG, VG, they form a hell of a lot of new compounds, and some of them, like isoprene, formaldehyde, those are things that maybe are not the best to do consume. So just a waterfall plot of compounds that you can potentially inhale when using PG and VG. How are those compounds found? This is a picture from Gira's paper from the Roggen group in Portland. And I will reference Gira's work a lot here, as he has been leading this field. How do we test for it? So you do it by GC and by LC. So GC, we have a GC single quad. Here, that's a picture of the setup at the University of Portland and the Roggen group. So GC with a single quad, and they have a headspace sampler. That's how they injected theirs. We normally did liquid injections as we captured the volatile compounds in an impinger, as shown. We also used LC QTOF for non-targeted full analysis to look for compounds we might have forgotten or not thought about. So here, a few data points and graphs. So you see in these traces, that's an LC trace here. No, this is a GC trace. Here in these GC trace, you see that the very volatile compound like isoprene, ketones, aldehydes, they come early. Then we go to the alkenes, and later on we see the aromatic compounds coming off, and obviously increasing number of carbons also coming through. Here is a slide from work by Zimmermann and his colleagues in Germany. They are at the University of Rostock and have their own company, Photon Ion. They basically have a direct inject QTOF, so no LC or GC separation. They inject directly into QTOF, which allows you to do online puff by puff analysis, which is pretty cool, but unfortunately a little too expensive for me. So here they were able to look at all these aromatic compounds within seconds for each puff and see how that behaves. So I think that's a pretty cool work too. So this is a quick cut out of the work we have been doing. We looked at vape cartridges, and then this is a quick table of our QTOF data. So let's focus on the larger table at the top first. So we ran both positive and negative mode. We're using the standard metabolomics methods from the university, so that we can use untargeted methods and just use their databases. And so their databases identified 45, 78 compounds already. Like, we are sure they are that. Then there are hundreds to thousands of compounds suggested, where we are pretty sure what it is, but not 100%. And then there are also a lot of other unknown compounds. So in the negative and positive mode, we found thousands of compounds we want to look at, and we are slowly working our way through this to understand what we actually found. As a quick cutout, that's the smaller table for one vape cartridge, or actually two vape cartridges here. We are looking at either the starting or the end position of the smoking cycle, and we are finding ethyl benzene, xylene, styrenes, and so then the regulator has to then consider, are these compounds one should regulate or not? And I leave that aspect to the experts. So using untargeted methods, at least sometimes in these studies, is quite useful because there is a concern of alteration. I already showed you that vitamin E acetate was identified after scrutiny, or after it became apparent one should look at it. But if you only look for your standard list of compounds, you will miss the others. So here, JWH18, the classic synthetic cannabinoid, was a concern in street drugs. If that is a reality, I don't know, but using untargeted methods would definitely be a good approach to just routinely check if such things come up. Okay, so why is vaping of concern? Because we see thermal degradation, right? If you have a heat source, you have organic compounds and potentially likely some oxygen around. There's a lot of stuff you can do. So Jiris and the Roggen group did a great work on looking what compounds could be formed, how are they formed, and at what concentrations. So here, and then they also grouped them into risk factors, and basically all of them are carcinogenic, right? And then they expanded this work. That's the Roggen group. They expanded this work to look at how the concentrations of those toxic compounds change in various methods of consumption. So they did dabbing, they did vaping at different voltages, and then could show that the basic trend is the more heat or the more volt you put on it, the more compounds you get. So if you look at the vape at 3.2 volts, the number is smaller than for all other consumption methods. So that led them to the point of thinking about a quantitative risk assessment, right? Life is not perfect. You can't get rid of all of them. So what might be the best method of consumption to at least lower your risk? And here they came up with some numbers in their risk assessment. And I just a quick tangent as Kyle is on the call. The question of risk and amounts, and not just yes or no of presence, is not only important for these toxic organic compounds, but also for heavy metals. And Kyle led the charge there, considering the question, do we inhale metals, and how much do we inhale? And so I just wanted to give him a quick shout out there. So, but when we then looked further into the literature, it's now back to Zimmerman. He had these nice graphs where he quantified nicotine inhalation, or concentrations of inhalation, per puff for various devices. So e-cigarettes, heat not burn, and straight up cigarette smoking. And it was interesting to see that the different kinds of devices deliver different concentrations of nicotine at different points of the smoke or vaping product life cycle. And that made us wonder, what about cannabis? Because So far, I talked all about the risk factors, and these are important to study. But what we hadn't discussed at all in this presentation is the quality. Like, you smoke joints or vapes not because you want to not have a risk. You consume it because of the benefits you gain from it. So now is the question, can we help you quantify these benefits? And then if we have a quantification of the benefits, can we then use it to optimize that product? And so here, further Puff 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 by the Zimmermann group, but now to our work. So we used 7 vape cartridges that I bought here in Canada from the legal store. And just for everyone in the US, I ordered it online with my credit card, and the Canada Post sent it to my door. So that's cool. And I think you down south are still dreaming of these systems. Anyway, so to show you here 7 different vape cartridges. We had vape cartridges that varied in weight from 0.4 grams to a gram in claimed oil weight. We actually smoked all these, or vaped all these these vapes from the start to the end, and weighed at the beginning and the end, and could tell you the mass loss. And if you see on the picture, we basically smoked it to the end, or vaped it to the end, and then we checked the mass loss. And we generally only found that 66% of the claimed weight that was filled in was actually lost. So I'm wondering, did they underfill? It was like not a single vape cartridge lost as much oil weight as they claimed they had filled into these vape cartridges. And this is not us collecting it, so capturing it, which I might have lost. No, we are just looking at weight loss. So I found this already some interesting tidbit of information. And then you also see in this table the average pad weight. So how many milligrams were deposited on our filter pads every 3 puffs, right? We did every 3 puffs to get a better average on a high enough number to actually see on our scale. And then we also counted the maximum amount of puffs we could get out of a vape cartridge. Maximum here, we actually smoked or vaped each product 3 times, or we had 3 repeats of those to get better average numbers. So here, now we come to the fun part of this presentation. How did the vape cartridges do? And if you quickly look at it, you can count 6 data points, or six different vape products. And I told you we did 7. One of them was a CBD product. So therefore, that doesn't really make sense to include, because here I'm showing you the milligrams of THC inhaled per puff. So single puff, THC milligram inhalation, and the positions 1, 2, 3 refers to the middle, the start, middle, and the end of the vape cartridge life cycle. So we took the first 9 puffs, we smoked it about halfway through, took another 9 puffs, and then we went to the end, get another 9 puffs that then started dry hitting. And here we then could show that there were some good vape cartridges. So the question is, do you want little or a lot THC? That also is dependent on the THC concentration in the vape oil. But what I would expect on a vape cartridge is that it delivers the same thing the whole way through, right? It's a homogeneous oil, it's a mechanical product, so it should be consistent. And we see a few that are relatively stable, but then we see like 2 products here. Let's see, you can see my mouse cursor. So I don't like this product here that like really dies off, or this one that like continuously trends down. So we can now put numbers on this, so we can really start thinking about oil and hardware and how they behave and deliver products to the consumer. But if you recall, I said the Roach isn't that bad. So yes, we also smoked joints on our machine. And here, so two joints, two THC joints that we rolled in-house. I didn't roll them, I can't roll, but we have skilled colleagues. And here we are looking at the THC concentration that you inhale per puff at the beginning, middle, and end of your joint. And it turns out the levels go up. Why do the levels go up? I think because THC doesn't actually go into the vapor phase, it stays in an aerosol. These aerosols will probably be captured or stick to anything they interact with, and therefore they should, the THC aerosol should deposit in the closer to the mouthpiece, the crotch of the joint. So I think it's not all the THC that you inhale per puff. There's some that deposits in the later state of the joint. And so when you get to the end of the joint, the deposited and the fresh THC is there for you to inhale. And so that's where the levels go up. That's a theory. So the next step for us is to actually dissect joints throughout the life cycle of smoking to then quantify the flower sections of a joint. And we will do that in the next weeks. And then the next time I get to talk about cannabis smoking to a scientific audience, which is really weird still, I can share that data. But so basically, important factor is if you want the most THC out of your joint, smoke the Roach. So here, just a quick comparison between our averaged out vape cartridges and the averaged out joints. Vape cartridges seem to decrease in THC concentration per puff during the life cycle, while for the joints, it goes up. And in this case of the vape cartridge, the oils we had averaged out and the joint we had, they actually start pretty good at the same THC levels. So vapes or joints aren't that far off each other in how much you actually consume per puff, which actually was surprising. If you think about it, right? The joint might have 20% THC in it, while a vape cartridge, you buy distillates for like, what, 80%, 90% THC in the vape cartridge. So we weren't sure if they were actually within even an order of magnitude. And it turns out they're pretty close. So that's pretty cool to see. Okay, so now we're coming to the part of the slides I just added minutes before we talk. As we will now talk about terpene quantifications in our joints and vapes. First, a shout out to our co-worker Ali for being really, really good at pipetting reference standards, setting them up for our calibration curve. If you look at our R-squareds, they're all double nines. We have a triple nine in there. So we were very impressed with how good the calibration curve works and how good Ali is in pipetting those reference standards. Okay, so here we are showing you a bar graph of the terpenes inhaled per puff for joints and vapes. And I have two graphs. The left one is monoterpenes and the right one is sesquiterpenes because they have different boiling points in average. So I therefore thought we should separate them and see if there's a difference. And if we quickly just look at the orange graphs, which are vape data, the numbers go up. So if you recall, the THC goes down but the terpene numbers go up, something I really did not expect. Terpenes have a lower boiling point than THC, so I would have thought, well, they might have go first. But we find they go up. You're missing the other part. The joints are in blue, and you for 6 possible bars, you only see 3. That's depressing. Is it that we rolled really, really bad weed that had no flavor left and there was no terpene to inhale? That was a bit concerning for us when we started looking at the data set. So what could that be? Why do we see so little and so inconsistent data for our joint? The answer comes when we think back of how we did our smoking. And I'm just jumping to the next step. So you recall that we are capturing our cannabinoids in the filter pad because they are in aerosols and they stick to everything they hit. So we want to capture them as quickly as possible at the mouthpiece and not send them through the piping where they could stick to the piping. So that's all stuff we validated and checked. So here, that's the picture on the left. On the picture on the right, that's the impinger, which we use to look for the very volatile compounds like isoprene, aldehydes, and benzene compounds, right? We used an impinger because we can't capture those on the pad. And this was the study we did for vape cartridges because we were specifically looking for toxicants. The joint was just an added fun project we did on the side, so we only used the pad. And therefore, if we go back in our data, and because we did repeats on the vape cartridges, we could actually look how does a filter pad, which is the orange here, so vape cartridge, filter pad, terpene concentration, how does that compare to the impinger captured terpenes in a vape cartridge? So that's the gray graph here. And what we see is that the filter pad is not good in capturing terpenes at all, right? The impinger is way better. For the joint, we only use the filter pad. And now if we look at, now the numbers are somewhat comparable between a vape. So if we look at the filter of a vape and the filter of a joint, these two bar graphs are somewhat closer to each other and therefore make sense. So now it makes us wonder how many terpenes would we have caught if we used an impinger for the joint. So lessons learned, but data only looked at this morning. So I obviously can't correct that data set for you in this presentation. And with that, we are getting to the end of this presentation. So I want to point out a lot of limitations. The journal articles I presented or referenced are generally done on non-real world setups. There's one paper where they used a vacuum pump to smoke a joint in one puff, right? And it was smoked in seconds. That is not a real, I don't know anyone that has that big lungs. Then the work by the Strongen group has been done on reference standards because they don't have the ability to use cannabis in their university in the US for so many reasons. Schedule 1 license, DEA allowance, then material from Mississippi, right? There's so many steps that prevent that. And the material used by Zimmermann in Germany were joints found by the police, and he got that out of the police custody. And those were cannabis mixed with tobacco. I still can't, spliff, I think they're called spliffs, right? So you mix tobacco with cannabis. So again, they have very little to do with what we consume here in North America. So these are issues. Also, these groups cannot collaborate because they can't ship material between them. So in our case, we are very early on. I just showed you, we only figured out to use impingers for terpenes after we looked at data this morning. But we are in Canada, we can use real material, we can collaborate because we can ship material back and forth between other universities, other license holders, and industry partners. So we are actually looking for industry partners or academics who will be interested in working with us on understanding smoking and vaping and then optimizing those products for the market. And so with that, I have to thank the collaborators and the great scientists that came before me that got all this going. So Professor Strongen, Juris, as mentioned multiple times. I had nice conversations with Professor Ralf Zimmermann in Germany. Oh, I forgot an N, sorry. It's 2 N's in Germany. And then Monica Villalpando and Linda Klumpers are always great sources of knowledge to talk cannabis. And I also have to thank my colleagues, my co-founder, Professor Glenn Samis at UBC, and my team. I already shouted out a few people. I want to mention then Sashni and Eric. Sashni, who runs the lab, admirably perfect, and she was the lead on developing the sample capture methods on the smoke cycle simulator. And Eric, our latest hire as an analytical chemist, he just produced all these bar graphs this morning, and he is the guy behind the GC and the LC. And with that, I thank you very much for your attention, and we still have time for questions, so I hope we will have a lively discussion. So with that, I stop sharing and we can see each other. Thank you.
Thank you for that, Marcus. That was great. We do have quite a few questions here in the chat, so I guess we'll start first off with some of the questions from Jehan here. So he's asking, what do you mean by smoke temperature, and what was the approximate temperature of the lit end of the joint?
Okay, so we have not yet been able to bolt an IR thermometer onto our instrumentation. That is still in the working, so I have to rely on literature work. They basically used IR thermometers or laser thermometers to measure the air that comes out of a vape cartridge. So we're looking at somewhere in front of it. The exact setup I don't know. I think I have one reference I can pull out relatively quickly. Jehan, I sent you that afterwards. But I also talked to some instrument manufacturers or hardware, vape hardware manufacturers that also measured the temperature of air that comes out of a vape cartridge at the front, and it hangs around 42 60 degrees. Depending on which one you ask, it might be 35, 45, 60 is the highest I've seen.
Okay, great. And there was another question in regards to the John W. Huffman compounds. When was JWH18 reported in CBD products? I know I've seen things like 5AF or 5FAKB or some other cannabinoids and other things, but they're and DXM.
I think that was the reference I had in my presentation. There was a Washington Post article. Let me just scroll back to it. Look, these are just journal articles, magazine articles I pull out. I haven't seen it myself. It was this Washington Post article, state authorities concerned by street drugs and CBD vapes, and JWH18 was mentioned. And yes, I also wondered, that's the compound you use to mimic THC. Why would you put it in CBD?
Yeah, makes sense. And then there was another question about, you basically said that you were able to recover exactly what the advertised amount was on many of these vape cartridges. So the mass loss that you were seeing, do you account decarbing in that mass loss, or were there any controls that were used to?
Sorry. Sorry, I must have misspoken or didn't present that correctly. So the numbers were not based on what we recovered. We didn't do recovered weight because there is the ability, right? There's decarboxylation, there's weight loss through decarboxylation, there's weight loss because your seals aren't tight. We just looked at weight at the beginning of smoking and weight at the end of the smoking of the vape hardware, and we just subtracted that weight loss, and that weight loss was never the advertised filling weight. So if it was, and I'm just looking at my slides here, 1 second, that I'm precise. Where we go? So if it advertised 1 gram of oil in it, we only had a mass weight loss, a weight loss of 740 milligrams. So only 74% of the advertised fill weight was lost when you consume the whole product.
Got it. Makes sense.
And so what you could, the other is you could open a vape cartridge, try to like scoot out the oil and put it on a scale and see how much oil you scrape out. But again, you might be imprecise with the scraping, right? There might be still an oil droplet left. So we really looked at, what do you actually consume? Like, how much weight can you suck out of this product? And not a single one got anywhere close to the weights advertised. And as I didn't fill, I can't say if it is a systematic problem or if it's just cannabis producers generally over-reporting.
Makes sense. We have another question here from Jehan. Were vape pens and carts kept in the parallel position to the combustion system as in the pictures? Typically, carts are in a 45-degree orientation to avoid the dry hit.
Yes, they were all horizontal. Should we look at, that might be an idea, we 3D print the mouthpieces so we could put a kink into it and see if that changes it. But at some point you have to standardize it somewhere, and there are then considerations to be had in a lab, what we actually can achieve. But we wanted the dry hit. So we were looking at the explicit request by our partner for this research was, what happens to the toxic compounds inhaled when you start dry hitting your vape? That's why the end position was always timed in a way that there would be a few dry hits.
Yeah, it makes sense, though. The orientation could really impact this, certainly. So I think that's a very good point. And it'd be interesting to see how the data turns out if you were to integrate that 45-degree angle. So I think that is all the questions we have for now. Does anyone else have any final questions for Markus before we call it? Feel free to unmute yourself, or you can ask the question in the comments. We'll give you guys just one more minute here.
I see Tim ask about water loss.
Water loss. That's right. I missed that one. Thank you.
How does that mean, water loss? So the vape oils would be dry. There shouldn't be any water in it. And so I wouldn't expect water to evaporate out of the vape cartridge prior to us consuming it. Because right, it's the weight loss beginning of the smoke, before we start smoking it or vaping it, and then at the end. So the water that might have evaporated must have happened then in the packaging before it got into our hands, between filling and us having it in our lab. But water doesn't really mix with cannabis oil, so I wouldn't assume there are any much water in there.
Yeah, sorry, Markus. To be more clear, so there's the water loss from some of the parts of the internal cart, right? So some of the silicone rings, some of the parts of the system itself have water in them that evaporates over use, which contributes significantly to the overall weight of the cart. If you weigh it at the beginning and you weigh it at the end, there's going to be weight loss, not necessarily from the distillate, but there certainly would be from other part of the hardware. Yeah,
we hadn't thought of that, but that would just mean that there was even less cannabis oil in the cartridge.
Right. Just a way to factor, again, just keep it in mind, if you're trying to reconcile the total particulate matter against the weight loss of the cart itself.
Yeah.
All right. Sorry.
Yeah, I was just also skimming through all the comments. So that's where I found Tim's one. And there was the discussion about the classic JWH18.
Yes. All right. Any other questions for Markus?
Yeah, Nigam here, Markus. Great presentation, by the way. I did have a question, though, about the x-axis on some of the graphs. There were two. One had like 1, 2, 3, and then the other one had beginning, middle, end. Can you clarify? Was that like 1, 2, 3 hits, and then how did the 1, 2, 3 correlate with the beginning, middle, end? I'm just really trying to track, understand how you were measuring.
You are right to point this out. Sorry, I tried to do that in my presentation. 1, 2, 3 refer to the beginning, middle, and end position of the smoke. So this is when I make graphs, I don't figure out how to put beginning, middle, and end at the bottom of the x-axis. But when my colleagues do graphs, they actually know Excel. They are able to put the text on the bottom of the graph. So that's the difference there.
So how can you share like how many? I mean, like how many hits are you taking? Like I'm just trying to understand because the comparison from the J to the what you were saying was super interesting about the actual amount milligrams. I believe on your y-axis it was milligrams, right, of delta 9 THC.
Yes.
Being intaken. So like
so just around a milligram basically per hit.
A milligram per hit. And then can you like speak to the size of the cartridge and also the size of the joint? I mean, we see the 3rd gram joints, we see the half gram joints, we see the gram joints, we see the the half gram cart, we see the gram cart. Like can you give us a little more detail on it?
Why not within the time frame here? So we're talking 7 vape cartridges, 3 smoke positions, 9 hits each. So we averaged out about 9 puffs per smoke position, per puff position. So the data set to go through that right now would be a bit too much. Averaging out over 3 or 7 very different products loses a bit of detail and specificity. And you also have to consider the THC concentration in the oil for the vape cartridge, because that affects how much THC you can inhale, right?
So totally. And I appreciate the data set. Thanks for sharing. I see Eric is saying in the chat though,
yes,
9 hits for each stage. So the whole data is 27 hits per.
Well, it's 9 hits at the middle. It's 9 at the beginning, 9 in the middle, 9 at the end.
I see, because you have to like work, you have to like let the rest of the oil out. So you're like taking 9 hits at the points you want to measure.
Yes, we take 9 hits where we want to measure it. Then we hit another 100, do another 100, and they just go straight into the hood and make the birds on the roof really happy.
Yeah, I bet.
Look, the days we do smoke experiments, everyone hangs out by the hood for some reason.
You're funny, Marcus.
So we then basically smoke 100 or puff 100 into emptiness. Then we do another 9 collections or 9 puff collections, and then another 100 that just out the door, and then we do the end position 9 puffs again.
Totally. Thank you for clarifying that. That's really helpful. I do just have one more kind of like more broad question. I really liked what you said. You had this statement, we detected thousands of compounds, and now we're trying to decide what to look into or something like that. So, I think that's something that to me makes a lot of sense, especially like just a complex mixture. I'm just curious, is there anything that really caught your interest, or maybe even like your kind of future outlook on analyzing those compounds? I'm just so
there's more to the story and more to come out, because we not only captured these compounds and then injected them into an LC QTOF, we also captured these compounds and then are shipping them off to a different group that will do in vitro studies on them. So they will just take these pads and will then mix them with their cell cultures and see who dies. So I think that will be quite an interesting combination of work. It's something we can't do, right? I have no idea how to culture anything. My house plants will die very quickly. So houseplant, inside joke. I'm in Vancouver, where Seth Roggen is from. A hashtag advertisement. So yes, there will be some in vitro studies to support our chemical work.
Awesome. And are you guys going to publish that? Can we look forward to the paper coming out later?
We did this work with a partner that paid us for it. So when the partner says we are publishing it, we are publishing it. If the partner says we're not publishing it, we're not publishing it.
Totally.
I'm at least able to talk about it in such a setting, right? I gave you the internal codes of the vape cartridges. I can't give you the exact products. I can't give you who the client is. So we have to skirt a fine line, but I'm trying to push for as much publication and openness of these data sets as possible.
Understood. Thanks again, man. Really great presentation.
Thank you.
All right, I think that concludes all of the questions, and we're at the top of the hour. So I'd like to thank Markus for the wonderful talk and learned a lot from it, so thank you. And stay tuned for next month. We'll be making an announcement for our June edition coming very soon.
Thank you very much. Have a nice day.
Thanks, everybody.
Bye.